All right, in this lab supplemental video, we will be focusing on this equation right here, which is the equation associated with heat transfer and heat transfer reactions. And so this equation has four different variables in it. There is Q, the heat that is being transferred. There is M, the mass of the substance being transferred, heat's being transferred in and out of. C, the specific heat of the substance, which is characteristic to that substance itself. And then dt, or delta T, sometimes it looks like this. And that indicates the change in temperature in degrees Celsius. So we can always find that temperature by taking the final temperature and subtracting from it the initial temperature. So in lab, we had two different substances that we were looking at their heat transfers and changes. We had mineral oil and we had water. Now, we had equal amounts of each of them, 75 milliliters of the one, 75 milliliters of the other. The question that we were looking to do is, over the 10-minute period, which one lost more heat? Which one cooled down faster? And so to do that, we're going to use this equation to go about figuring that out by solving for Q. So for the mineral oil, Q is equal to the 75 milliliters multiplied by its specific heat, the specific heat of the mineral oil comes from your lab manual. Lab manual says that the specific heat of the mineral oil is 1.42 joules per milliliter degrees Celsius. And then the heat change, our mineral oil, our initial temperature was 78.2 degrees Celsius. And our final temperature for the mineral oil was 44.0 degrees Celsius. So if we do the calculations, 75, well, let's do the subtraction first. 44 minus 78.2 would give us negative 34.2 degrees Celsius times 75 milliliters times 1.42 joules per milliliter degrees Celsius. We get a grand total to two significant figures of negative 3,600 joules. So the negative value here indicates that we have lost energy, which makes sense because the mineral oil went from a hot temperature to a cooler temperature. And so, yes, we did lose energy in that process. Now, let's contrast that with our water. Water, Q is equal to 75 milliliters times its specific heat, 4.184 joules per milliliter degrees Celsius, times its change in temperature, and its change in temperature, it also ended at 44.0 0.1 degrees Celsius, but it actually started at 66.0 degrees Celsius. So if I do my subtraction, 44.1 minus 66, I get a negative 21.9 degrees Celsius. So we can see if we compare the two substances side by side, we can see that the water lost a lot less temperature. Now let's see if that computes to any kind of energy. Negative 21.9 times 4.184 times 75. We actually see that from a heat standpoint, the water actually lost a lot more energy, negative 6,900 joules. So the interesting thing about specific heat is that specific heat tells us a lot about how much energy is required to change temperature. And what's really interesting about that is it takes a lot of energy to heat something up. It also means that it takes a whole lot more energy to cool something down. And so even though both of these substances ended at essentially the same temperature, it took a lot more energy for the water to get there than it did for the mineral oil. So I hope this helps with the calculation. If you have any questions, feel free to reach out to me, email me, or send me a message. And I will look forward to seeing you in our next lab.